Powerful Pythonistas, it's Prof G with a lesson to clarify some confusion that sometimes occurs when wiring up NeoPixels. My students started off working with NeoPixels built into the Circuit Playground Bluefruit, and then they moved on to these 3-wire NeoPixel strips with alligator clips. And these strips have 3 wires, power, signal, and ground, and they're almost always colored red for power, white for signal, black for ground. But then we start working with other NeoPixels, and the wiring can be different. For example, here's an ultra-thin strip of 160 NeoPixels that I bought off Amazon, and here is a standard 32 by 8 flexible NeoPixel matrix. This is the kind I use in my Sonic Towers build, where I wired 8 of these together in each tower. And if you look at these wires, well, there's red power, but then the middle one is green, and the other end is white, and there's no black. What gives? Well, it would be nice if the colors were standard, but you can't rely on color. So in these red, green, white types, the wire pattern actually is the same as the red, white, black type. So red is power, the middle, green in this case, is still signal, and white instead of black is ground. So these ones have power, signal, ground, red, white, black, and these ones also have power, signal, ground, but it's red, green, white. Now, it is quite common for power and ground to be separated with signal in between. That's usually the best case from a wiring standpoint because you don't want your power and ground to touch each other, but that's not the case in all electronics. For example, here's a standard micro servo motor, and these often have yellow, red, and brown, which is signal, power, ground. The power and the ground are next to each other. So definitely check. Most products have a spec sheet that you can look up online and clarify things, and it can get worse. So I actually bought these ultra-thin NeoPixels on Prime Day, and they were listed as 12 volt, and NeoPixel is Adafruit's term, so sometimes you'll see these standards referred to as WS2812 outside of Adafruit. These are designed for 5 volt, not 12 volt, despite what the Amazon listing says. Now, normally you wouldn't buy anything listed as 12 volt and expect to power through your Pico, as I'm doing here, but the WS2812B standard is a 5 volt standard. It's pretty easy to get confused by this. The web page suggests that you can use a 12 volt power supply if you have a separate power supply on these lights, but I don't think the product page is very clear. And this is one of the reasons I like buying from Adafruit. The more off-brand you get, the more bad information and poor packaging you might see. For example, on my lesson on this 2.2-inch TFT display that I bought on AliExpress, I pointed out that one of the pin labels was actually printed upside down when compared to the other pins. New students and just about everybody could do without the extra confusion. Well, now that we know how to wire this up, these connectors don't have alligator clips and they don't have pin wires at the end. That's a problem because you probably want to pin this into your breadboard if you're working with a Raspberry Pi Pico or similar microcontroller. Now, these connectors are called JST SM 3-pin connectors. They're the most common type that you'll see with the WS2812 standard. That's the NeoPixel standard for LED lights. Now, many times when we talk about cables, you'll hear folks use terms like male and female. I actually think that's creepy, so I try to avoid that language. We don't need to gender our wires, but it gets even worse because the pins are hidden inside of these receptacles. So I've actually seen diagrams that have different labels for sides. Sometimes this is called the male end, sometimes it's called female. So in order to avoid confusion, I'm going to call this one the end with the side arms or the side tabs, because these tabs here are actually little locking arms that create a secure connection. And I'll call the side with the tab at the top tab side. When you slide these together, they'll snap. You know you've got a secure connection, and if you press the top tab down, you'll release the connection. Now, you might already know that NeoPixel standard lights are directional, so the signal flows from an input through an output end, and you can't send your signal in the other direction, your lights won't work. So you might wonder, why don't I just call this the input side? Because on both of these NeoPixel sets, the strip and the LED matrix, the end with the side arms is the input. This is where the signal comes from either the microcontroller or the prior set of NeoPixels if you've got these daisy-chained in a group. Well, friends, you can't rely on all connectors with the side arms to be inputs. And here's an example. I have a NeoPixel strand here, and the input end is the one with the tab on the top, not the arms on the side. Yowza confusing. So how do you tell which end is input and which end is output? Well, in the best case scenario, your lights will be clearly labeled as input, sometimes DIN for data in, or sometimes on lights you'll see little arrows showing you where the signal flows. So the arrow tips point toward the output side. The input end is the opposite of where the arrow is pointing. But if you don't see that, look at the data sheet. You should be able to find something online from the manufacturer. And also know that even though these lights are directional, if you plug the input into the output side, you won't blow anything up. You just won't won't see your lights go on. So if nothing works right on one end, you can just flip over and try the other connector. Now, how do you get these lights connected to your breadboard? This JST connector doesn't have pin plugs for the breadboard. Well, you can stick pin-pin wires to connect this side arm input end to a breadboard, or pin socket wires with the socket end of your wires going into the metal pins that are inside of this top tab input. But I'm going to ask my students to practice soldering by soldering up their own connector. So they're going to take 3 wires. These are standard jumper wires. Just make sure that you got pins on one of the ends. I like to stick with the colors red power, white signal, and black ground, but it doesn't matter. But you should try to wire your power up to red or a color that's closest to red-like in your group of 3. And to do this, I'm going to clip off the end of one of these DuPont jumper wires. Make sure the pin is at the long end. It doesn't matter what's on the other end because we're going to discard it. Then strip the cut end so that there's about a 1/4 inch connection, and then take whatever is the opposite JST SM connector that you need. In this case, the input JST connector that I'm trying to connect to has side arms, so I'm going to wire these 3 wires that I just cut into its opposite one, the end with a tab on top. Strip the wires coming out of this tab on top piece so that there's also a 1/4 inch at the end. And I usually slide the heat shrink into one of the sides of wires here before soldering them. Sometimes the heat shrink is big enough that you can slide it over the pin end of the wires, but not all the time. So to be safe, I put the heat shrink on before I solder. And I like to tin the tips of the wires, which means put a little bit of solder on the end of the wires. That just makes it a little bit easier for the solder to flow between the 2 wires and make a secure connection. Some people like to twist together wires and then solder those bare wires. You can use whatever you want. Also remember that flux can help things flow so you get a solid connection. Solder the wires together and then slide the heat shrink over any exposed wires and use a heat gun to seal the heat shrink around the wires. And then you've got a handy 3-pin connector that you can use as the opposite for the input JST connector for your Neopixels. And you can see I can reuse this connector on this Neopixel strip or this 32x8 NeoPixel matrix. As the millennials say, totally lit. Now, I hope you found this to be useful, big learning. Drop some love on the channel to help others find these fabulous free open courseware lessons and use your skill to make something awesome.